Today we shall see properties of acids. In this we will cover the physical properties as well as the chemical properties. So let's first start with the physical properties. The first thing that we see in the physical properties is the taste. So what is the taste of an acid? Acids are generally sour in taste. Mineral acids like sulfuric acid and nitric acid are highly corrosive in nature. That is, they can burn the skin, and that is why they should not be tasted. But by and large, all the acids are generally sour in taste, and we can know that from some of the organic acids like citric acid, tartaric acid, etc. So, acids, first thing, it has sour taste. Okay, now let us see the second physical property, that is the physical state. So we come across most of acids which are in liquid state, but there are also a few acids which are in solid state. Many of them are in the liquid state. Okay, so let's see some examples here. We have boric acid, oxalic acid, tartaric acid and citric acid. These among the few organic acids, and there's again phosphoric acid. These acids are solid in nature, whereas most of the other acids that we have come across like acetic acid, formic acid, carbonic acid, hydrochloric acid, nitric acid and sulfurous acid, these are all in liquid state. Even sulfuric acid is in liquid state. The reason sulfuric acid is written separately is because sulfuric acid is a non-volatile acids, and all the other acids right from acetic acid to sulfurous acid, these are volatile acids. And what do you understand by volatile acids? That is, they vaporize very easily at room temperature or by heating at about around 100 degrees. So these acids can form fumes at around room temperature to 100 degrees Celsius, and hence they are called volatile acids. Okay, so now let us see the next physical property of acids, that is the effect it has on skin. So all strong mineral acids, which are these strong mineral acids? Sulfuric acid, nitric acid, hydrochloric acid. All strong mineral acids have corrosive action on skin and cause painful burns. Okay, so concentrated sulfuric acid stains the skin black. Concentrated nitric acid, one of the most corrosive acids among all these mineral acid, gives yellow burns on skin, and concentrated HCl, hydrochloric acid, gives amber color burns on the skin. We also see that there are many acids which are organic acids or even carbonic acid, which is not corrosive in nature. Carbonic acid, as you all know, it's present in sodas and soft drinks and colas, and organic acids are present in many of the fruits which we can have consumed without any problem. So mineral acids have corrosive action and they do cause painful burns. The next physical property of acid is that it changes the color of indicators. Before seeing what this property means, let us first see what are indicators. We have already seen them in our labs: methyl orange, phenolphthalein. These are all indicators. So indicators are substances. They are complex substances that acquire different or separate colors in acidic medium and in a basic medium. For example, litmus indicator, it is a natural coloring material matter obtained from certain lichens on dissolving in distilled water. So there are these indicators that with the change in color specify what type of medium it is. So generally one physical property what we need to know is that the acid will change the color of the indicator. Now we'll see in the next slide how. Okay, here in this screen we see some of the indicators and the color changes in acidic medium. So when you have a litmus indicator, it changes from blue to red in an acidic medium. Methyl orange changes from orange to pink in acidic medium, whereas phenolphthalein remains colorless in acidic medium. So phenolphthalein does not show a change in color in acidic medium. Now we come to the next point, that is electrolytes, the physical property of acid. Now since acids are made up of hydrogen ion as a positive ion, when they are dissolved in water, they are capable of generating hydrogen plus H plus, that is hydrogen cation, and this helps to conduct electricity. So generally most of the acids are electrolytes and they do conduct electricity in their aqueous state. So this is one important physical property for acids. Okay, now let us see chemical properties. Uh, the properties that we are seeing, the physical properties and chemical properties that we see in this chapter, children, we are going to see this in detail, and these portions, these reactions will be repeating in the next three chapters, that is your hydrochloric acid, nitric acid and sulfuric acid chapters. We have three acid chapters coming in after this chapter, and you see that the same kind of chemical reactions will be shown in all these chapters. So please try and understand these properties carefully. Okay, so the first chemical property is the reaction with metals. So both dilute hydrochloric acid and sulfuric acid react explosively with active metals like potassium, sodium and calcium. They react moderately with less reactive metals like magnesium, zinc, and in both the cases they produce metallic salts, that is the corresponding metallic salt. So the examples shown here are of the moderate or the less active metals, but it also reacts with the very active metals like potassium, sodium, but the reaction will be very explosive. As we know that the sodium and potassium can react even with air and water, so naturally even if it is acid, the reaction is going to be very explosive. So in all the cases we see that the metal reacts with acid, giving us the corresponding salt and hydrogen gas is released. Now nitric acid, there's a note here, so sometimes this question can come. Nitric acid is a very strong oxidizing agent, so it is not used in the preparation of hydrogen, like we have seen in classes 8 and 9 that we have seen preparation of hydrogen. So most of the books refer to the reaction with zinc plus H2SO4 or zinc plus HCl, but we don't see a reaction of zinc with nitric acid, and the reason being nitric acid is a strong oxidizing agent, hence it's not used for preparation of hydrogen generally. Okay. Okay, now we have the easiest and the next chemical property, that is neutralization. We know this from our lower classes that acids react with bases to give us salt and water. So the important chemical property of acids is it can react with base, and such reactions are called neutralization reactions. So you see any acid can react with a base. What's a base? A base is generally a metal oxide or a metal hydroxide. So it reacts with a metal oxide or a metal hydroxide to give the corresponding salt and one water molecule. So this is the neutralization reaction, which is very simple and it's important as well. The next property is the reaction with carbonates and bicarbonates. Carbonates and bicarbonates. Bicarbonates also called as hydrogen carbonate, that is a HCO3. So as I've already explained to you, when an acid is going to react with carbonate, what does carbonate contain? Carbonate contains CO3. So naturally from CO3 what it's possible to get? It's possible to get carbon dioxide. Now CO3 has CO2, and that is why it will be able to give you carbon dioxide. So acid liberate carbon dioxide on reaction with metallic carbonates or metallic bicarbonates. Let's see in the next slide the reactions for the same. Okay, so in the screen we see the carbonate, metal carbonate or bicarbonate reacts with acid to give us the corresponding salt, water and carbon dioxide is evolved. So CO2 comes out of the carbonate from the CO3, and one of the oxygen from the CO3 adds up to the hydrogen from the acid, and that's from where water comes out. And the corresponding salt, since we are taking HCl in this, so the salts are chloride salts in both the cases. Okay, so if the salt produced is insoluble, then the reaction does not proceed. So we do not expect lead carbonate to react with hydrochloric acid or sulfuric acid. The next chemical property is the reaction with sulfites and bisulfites. So acids react with sulfites and bisulfites of metals to liberate sulfur dioxide. Naturally, sulfites and bisulfites, that is SO3 or HSO3. It contains SO2 also. It's a part of SO3 or HSO3. Hence, what we are going to get, how we saw that the previous reaction gave out carbon dioxide, in this case we are going to get sulfur dioxide. So the reactions are very simple. The metal sulfite or bisulfite with acid gives us salt, the corresponding salt, water and sulfur dioxide. Only you should know from where that SO2 is coming. In the previous case, from where that CO3 is coming out. The CO3 was coming out from the carbonate. In this, SO2 is coming from the sulfide group, sulfide radical or bisulfite radical. Our next chemical property is reaction with sulfides. So acids react with metal sulfides to liberate hydrogen sulfide. So hydrogen sulfide is a gas, so in the reaction you are going to show it with arrow sign upward. And I hope that you remember what is the special quality of H2S gas. It has a very awful smell. It has a smell of rotten eggs. So metal sulfides react with acid to give you salt and hydrogen sulfide. Okay, now the next chemical property is how do acids react with chlorides. So the reaction with chlorides here. Chlorides do not react with any of these dilute acids. In general, chlorides react with concentrated sulfuric acid on warming to liberate hydrogen chloride. Okay, now this is a very important reaction, which is also the laboratory preparation for hydrogen chloride gas, from which we are going to get hydrogen chloride acid, HCl, hydrochloric acid. So this reaction is one of the most important reaction which you need to study and really know very well. So it's a very simple reaction. Salt and concentrated sulfuric acid below 200 degrees gives you sodium bisulfate plus sulfuric acid. The same reaction if it happens above 200 degrees, instead of sodium bisulfate we get sodium sulfate and 2 molecules of HCl. The previous reaction is preferred and we will see that in our next chapter. So chlorides, metal chlorides can react with concentrated sulfuric acid to give you another volatile acid. Okay. Now the next property is reaction with nitrates. Nitrates do not react with dilute acids. However, lead nitrate solution reacts with both dilute HCl and dilute H2SO4. That is lead nitrate solution. You can have reactions even with dilute hydrochloric acid as well as dilute sulfuric acid. But in this case, they form insoluble lead salt. So we'll get an insoluble salt. So you see a precipitate that is going to form in this case. Okay, now let us see some general uses of acids. Let's see, boric acid is used for eye wash or it is used in antiseptic. Next, citric acid is used as a food preservative. It is also used in the preparation of vitamin C. Oxalic acid, it is used in ink stain removers. Carbonic acids are used in flavored drinks like Coca-Cola, etc. Tartaric acid is used in baking powder. Acetic acid, it is used in vinegar as well as it is used for cooking. Hydrochloric acid, it's used for cleaning metal items. We have a separate chapter on this, so in that we will see this particular use and this particular acid in detail. Benzoic acid, it's used for preservation of food and making of perfumes and medicines. So benzoic acid and its use. Nitric acid is used in explosives. Again here we have one more chapter, nitric acid, that's coming in later. So we'll see this as well as in detail. So nitric acid explosive, this is important. Hydrochloric acid for cleaning metal items, this is important. Phosphoric acid is used in fertilizers. So these are some of the general uses of acids. And when we are going to study the next 3 acid chapters, we will see the use of the particular acids in more details. So that's it for today's explanation. So with this we have covered up all the information that you need to have on the acids part of this chapter. So in the next class we will see bases.